Hi, this is going to be the second part on squares and square roots, and we're just going to jump right into it. The square root of 400, I know I showed last time you can break it apart into the square root of 4 times 100, which, awesome, square root of 4 is 2, square root of 100 is 10. Let's backtrack a little bit, and let's go back to the fundamental idea of it. We can find this by, man, I'm burning that thing. I hate that thing. We'll just break it apart. I know this is 4 times 100. I'm not going to do my fancy trick of splitting them apart. That's a great move, but I'm not. By the way, if you don't do it, I would recommend the balance line to make this look a little nicer. I know 4 is 2 times 2, and 100 is 10 times 10. So I'm breaking them apart into something that's a little easier to work with. Working with square roots, let's go back to the base idea. It is the number, it's some factor multiplied to itself, and we only want to keep one of those. So I want to make two numbers that are the same, then multiply together. Well, if I do a little fancy commutative property of multiplication, I can rewrite this as 2 times 10, 2 times 10. Well, 2 times 10 is 20. 2 times 10 is 20 because I can use associative property of multiplication. So really I'm taking the square root of 20 squared. That's what I want to get to. I want to get the sum number squared because the square and the square root undo each other. So my final answer would be 20. It is a different way than we were doing earlier. It's actually quite different than what we were doing earlier. However, it's something that we're going to be doing with the examples I'm going to show in a minute. Let's practice again with B. Let's just do it with B real quick. I don't want to show what's underneath my hand because that's going to take away the surprise of why we have to do it this way. Let's look at the square root of 2025. Okay, well, it's got a 5 on the end of it, and I would be willing to bet it's probably divisible by 25 because if it's got a 5, I haven't given you anything that's too crazy yet, so it's probably going to be 25. So let's just play with that idea. Oh man, I did it. By the way, you'll start doing that too. You'll start putting square root instead of divide, or divide instead of square root. I do it all the time. I'm just going to square root 25 into here. By the way, again, remember the rules. This has got a 5 in the end of it. I know I can divide something by 5. I also know 20 divided by 5 is 4, and 25 divided by 5 is 5. Like, go with those ideas, those hints, those gut feelings. They work. 25 doesn't go into 20, but it definitely goes into 200, and it goes into 200 8 times. So I'm going to minus 200. I'm going to have 2 left over, bring down a 5, and hey, 25 goes into there one time. Holy cow, what did this just turn into? This just turned into, well, this is 25 times 81. So that's 25 times 81. If you want to do a factor tree, I'm all for that too. That will definitely help maybe. You know, like I'm all for different approaches. It depends on who you are and what you like to do. This is 5 and 5. This is 9 and 9. And right there, I'm going to stop. I don't need to go all the way down to the 3s. 5 and 5 are the same. 9 and 9 are the same. Now I can use my properties and play with it a little bit. So this is me playing. I like to play. This is the square root of, well, that's, again, 5 times 5. This is 9 times 9. Commutative property of multiplication, I'm going to rearrange it to 5 times 9 times 5 times 9. 5 times 9 is 45. Times 45. I'm going to have the square root of 45 squared. And at that point, I know I'm out of space, but it's equal to 45 because the square and the square root cancel. That's kind of what, so we factor, we're doing all these great things. That's the idea though. I want to turn this into something to the second power so that the second power just goes away and it's whatever's left over. Like, so the second power and the square cancel each other out because they are inverse operations. So the answer to this one's 45. Going with that idea, here we go. M to the fourth power. Wow, Mr. V, what are we going to do now? Well, here we go. I'm not going to use that mechanical pencil for starters, even though I automatically went for it. This is M times M times M times M. I want something times itself. I want those two things to be the same. Well, I can do M squared times M squared. That's perfect. Oh, now we're going to get into craziness. Here we go. That means this is equal to M squared, because there's two, because that's what they both are. They're both M squared. They're both the same. So I can square that. Think back to our properties with exponent properties. Now we're going even further circle. Full circle. Further circle. That was really bad, but never mind. Okay. An exponent raised to an exponent, I can just multiply. Hey, look. 2 times 2 is 4. Well, and if you're good enough, some people just go from here to here. Some people. Take your time. The square root and the square cancel, so all that's left is M squared. My one question is that going to stay positive? Yeah, anything squared is going to be positive. Have you noticed that? If I plug a negative in, 2 is a even number. Remember, this even goes back to the first unit, the natural exponents. We were doing this. It's an even number, so yeah, it's going to be positive. We're good. What happens if it isn't positive? That's a great question, too. Got a few more examples for you. Well, let's see. 1, 2, 3, 4, 5, 6. If I want to be real careful, hey look, these are the same and these are the same, because that's what I want. So really this is c to the third times c to the third. C to the third raised to the second power, not 6, second power. Okay. And now the square and the square root cancel, so all that's left is c to the third. What happens if c is positive? That's a great question. This over here would have made it, or negative. This would have made it positive. So whatever we happen to do, this would have become positive already. So whenever we see this, we have, if it's an odd power, we have to put an absolute value around it, because it's going to be whatever it was, but positive. Little tricky. We'll talk more about it in class, I know. Mr. V, do we have to write this out completely every time? No. I know I need to get something to the second power. That's what I need. Do it case by case. Oh, wait, sorry. That's not how I was going to do this one. Where's my eraser? I was going to do that one, this one a little different. What if we have two variables? That's what I was going to say. What if you have two variables? Great question. Square root of x to the fourth times square root of y to the sixth. Again, think about what we did the first part of this lesson. You can split it apart. That's fine. Oh, you can split it apart because of this. Is a little bit of a reminder. A square root's nothing but a nasty looking exponent. Because of this law right here, we can do this. That's why it's true, because it's basically an exponent. So it follows the exponential properties. That's why we can do that. I'm glad I remembered that. I was like, there's a reminder right there. I should probably say the reminder. This is square root of x squared squared times the square root of y to the third squared. Yes, you have to show that. I really, really want you to show that step. Don't automatically jump down here. This is x to the second power. This is y to the third. What happened up here? I said if the variables, you have to put it in absolute value. You have to. Just because your answer has to be positive. X squared's fine. You could also, if you wanted to, just put the whole thing in parentheses. That's also fine. But this is probably more, this is the way you'll probably see it on a test. Okay. Part D. Again, I'm gonna use my little fun trick over here. Because of the exponential property, I can do this. And yeah, 25 is a coefficient. Who cares? The square root of 25 is 5. I will take my time and show it. But yeah, the square root of 25 is 5. Square root of this, let's see, I want to the fourth power, right? 2 times 4 is 8. So it's equal to 5 times, or 5n to the fourth power. N is an even power, so I don't need the exponent, so we're good. Mr. V, you ain't funny. Like, you're not a funny guy, you stand in class and joke. That's not cool. Yeah, I know, right? But it's crazy fun. I love problems like this, because it gets ridiculous. Here we go. I'm gonna split it apart. Again, think about how I always explain things. You do it piece by piece. I'm gonna do the coefficient. This is just like how we did raising a power to a power. Remember monomials to a power? Take the coefficient, raise it, put it in the square root. Put the variable, put it in square root. Take the other variables, put them all in their square root. This is 50 squared. Because I know 25 is 5, and I know that 100 is 10. 5 times 10 is 100. This is, oh, this is going to get tricky. You could put r in parentheses, a square. That'd be fine. This is s squared, squared again. This is t to the fifth, squared. Right? See, the first one turns into 50. That turns into r. That turns into s squared. That's t to the fifth. The 5 is an odd power, so I gotta put times the absolute value of t to the fifth. In case t happens to be negative. Again, it's a variable, it could be anything. That's why we have to do that. That's squares and square roots part 2. A lot going on. So there you go. We'll work on it more in class. See you next time.